Okay, so now we have this idea of function transformation. So think about reflections, x-axis and y-axis, horizontal shifts, vertical shifts, and also horizontal and vertical stretching and compressing. Now that we have those, if we know a basic function shape, so think about our parabola, and we know the transformations of that function, we have a nice way of sketching a graph of that function. So what our goal is for this video is we want to figure out basic function shapes for all of these functions listed up here. Because if we do that, then we can also figure out how to transform them using reflections, shifts, and stretches, okay? So in order to figure out these, one thing we could do is we could go through and plot points and do a lot of plotting points and things like that. Instead of doing that, what I'd like to do is use Desmos to plot the points for us so that we can get a picture of what is going on. So I'm going to switch over to screen share. Okay, so now on the screen, you should see kind of two things. One is the little activity that we're going to be going through, okay? And this activity sort of is going to step us through the process of figuring out what different basic shapes look like, and we're going to use Desmos rather than doing this by hand. So that's our little activity that we're going to go through, and then we also are going to use Desmos to actually do the graphing for us, okay? All right, so first thing we need to do is we want to sketch a graph of this linear function, f of x equals -5/3 x plus 6. Now, what do we know? Well, we know our y-intercept right here at 6, and we know our slope at -5/3. And using those two things, we should be able to sketch a graph of this function. So we want to sketch something like this. What do? Well, we know that our, and I'm going to try and do this with my little grapher tool here. So we know that our y-intercept is there at 6. We can think of our slope as directions. -5/3 we can think of as down 5 and over 3. So down 5, 1, 2, 3, wow, I can't count, 4, 5, and over 1, 2, 3. So there's our other point. And then if I draw a straight line, drawing a straight line is going to be very challenging for me. I'm going to do my best here on the screen. If we draw a straight line, okay, so pretend like that's a straight line. There's a graph of -5/3 x plus 6, okay? Now, similarly, if we want to sketch a graph of a quadratic function, well, we know the basic shape of a quadratic. The basic shape of a quadratic is that parabola shape, okay? And what have we done to this parabola? Well, this negative is an x-axis reflection, so we flipped it upside down. This 1/2 is a compression, a vertical compression, so our parabola is going to be wider than original. This -2 is a horizontal shift, so that's right 2. And then this +3 is a vertical shift up 3. So I'm going to take my original parabola, which started here, had a vertex at 0, 0, and went up and up, and I'm going to move it to the right 2 and up 3. So there's our new vertex. And then I'm going to flip it or open it down, x-axis reflection, and it's going to open wider than original. So again, this is just a sketch, but there is a nice sketch of our little parabola there, okay? So we know how to sketch those two things. Now what we want to do is figure out how we sketch other things, okay? So in particular, we're going to look at some additional basic function shapes. So we're going to start by looking at the x cubed graph and the x to the 4th graph, okay? So x cubed, if we sketch a graph of x cubed using Desmos, okay? So f of x equals x cubed. So here's a basic cubic graph. It has this shape that I call an S-curve. That's my terminology, not really general math terminology, okay? Starts at 0, 0, so that's the starting point of 0, 0, and goes up and down like this, okay? Now we could have gotten this by plotting points. So for example, we could plot points by saying, if I plug in 1 to this function, 1 cubed is 1. If I plug in -1 to this function, I get out -1, 0, 0. So we could have plotted this by plotting points, but it's just nice that Desmos does it for us. So I'm going to go ahead and sketch that on our page over here. So let me switch over and sketch. So I'm going to sketch that S shape. So up on the right and down on the left. Now that's not a perfect sketch one because I'm real bad at using the sketching tool on my screen here, and 2, just because I'm just not good at sketching in general. Okay, once we have that sketch, however, let's think about the domain and the range of this graph. Well, our domain is our x values. Now, this arrow here tells us this is going to continue to get wider and wider and wider on both sides. So our domain is going to be everything. Our domain is going to be -infinity to infinity. Again, I apologize for my poor writing ability here. And how about our range? Our range is our y values. So again, that's going to be everything going up and everything going down, or again, -infinity to infinity. Okay. All right, so that's the x cubed graph. Now, how about the x to the 4th graph? Let's look at the x to the 4th graph. Okay, so I'm going to change this to the x to the 4th graph. Okay, And look, we have something that looks very similar to a parabola. If we compare that to our first parabola we looked at, the x squared graph, it's a little bit narrower, and that makes sense. If we think about what points go into this, if I plug in 1, I'll get out 1. But if I plug in 2, well, 2 to the 4th means 2 times 2 times 2 times 2, which would be 16. So if I wanted to see where 2 is, I'd have to go all the way up here to 16. So the point 216 and also the point negative 216 is on this graph. It's still kind of that basic U shape, however. So let's go ahead and sketch that in, our basic U over here. So kind of same general shape. It's a little skinnier than our original parabola, but we still call it that U curve. And now let's think about the domain and range here. Well, the domain of this, again, is going to be everything. This side of the parabola is going to extend to eventually hit all the positive x values. This side is going to extend to hit all the negative values. So our domain is, again, everything, negative infinity to infinity. Our range is going to start at 0 and go to infinity. So our range will be 0 to infinity. And if we think about our endpoints, 0 is going to be included, so that's a bracket. And infinity, we never include. Okay, so here's those basic shapes. Now let's think about if we wanted to take our transformations and apply them to these basic function graphs, okay? So let's look at this graph here. F of x equals negative 2, x plus 1 cubed minus 3. So my basic shape is my cubic graph. How do I know? I know because of this little cubing here. That tells me the basic shape, the untransformed shape, looks like this. So this is the shape I'm going to transform. Now what have I done to it? Well, this negative here is what? That's an x-axis reflection. So I flipped this upside down. I'm going to go ahead and sketch what that would look like. Here's our x-axis. If we reflect it, we would get something that looks like this. That would be our reflection of that purple graph. So we've reflected it, and then we've moved it. This is our horizontal shift. That says we've moved it left 1. So if I move this left 1, I'm going to shift everything over 1, and it would look like this. And then last, this negative 2 tells me that I've shifted everything down 2. So then when I shift everything down 2, my graph would look like this. So there's each step in the process. Now what I'm going to eventually do is just redraw that graph here. So I think about my starting point 0, 0. It shifts left 1 and down 2. So it's now there. And then I've reflected this. So I draw then my, what I call reflected S-curve. Okay, so here's a sketch of that transformed graph. And from that sketch, we can think about the domain and range, right? Well, does the domain and range change? Our domain is our x values. This is still going to eventually expand and hit all x values. So our domain is still negative infinity to positive infinity. And similarly, our range is still negative infinity to positive infinity. Oh, that's a really bad infinity. Go with me on the journey, sorry. So our domain and range in this case didn't change. Now let's do the same thing over here with this graph. F of x equals negative 2/3 x minus 1 to the 4th plus 4. Okay, so this is a transformed 4th degree graph. I know that because of this little 4 here. That tells me the basic shape is this U curve here, okay? All right, so that's my basic shape. What have I done to the basic shape? Well, again, this negative out in front is an x-axis reflection. So I've turned this upside down, so it now opens down. That's our x-axis reflection. This 2/3, that's a compression. Why is it a compression and not a stretch? Well, 2/3 is smaller than 1. So remember that a compression makes my graph wider than it was before. So this is a vertical compression. So that's where our graph is at now. And then how about this -1? This -1 is a horizontal shift, and it's a horizontal shift to the right 1. So now my wider graph is over here. And then last, this +1 is a vertical shift up 1. So then I take that wider graph that I shifted to the right 1, and I'd also shift it to the left 1. Now you can see it's starting to get really messy there, and that's why we tend to redraw them on a new graph. So putting all of those things together, I shifted right 1 and up 1. So that's kind of my new starting point. I reflected, so my graph is going to open down. And I also know that my graph is wider than it was before. So there is my sketch. Now again, I'm using that word sketch. Now let's go ahead and compare that to what Desmos shows. Okay, so I'm going to start with the one that we just did. So we had our initial graph, f of x equals x to the 4th. And then our transformed graph, I'll make it red also so it matches. Our transformed graph was negative 2/3 x minus 1 to the 4th plus 1. Now, does that look similar to what we had here? Similar enough for a sketch. It's got kind of its starting point right there at 1, 1. This one has its starting point there at 1, 1. Okay, it's been compressed, not very much, but it certainly is a little bit wider, and it opens down. Now I maybe did a little bit too much of my compression, but again, that's why we call this a sketch. So in general, this is a pretty good representation of this. And one of the reasons we like to sketch these is it gives us a nice way of finding domain and range. So let's think about the domain and range of this. Well, domain is still going to be everything, negative infinity to infinity, right? It's still going to take on all of the x values. Our range, however, is pretty different. Our original range was 0 to infinity. Now our range, our y values, is going to start down here at negative infinity and go up until it hits 1. Once we get above 1, there's no graph. So our range is going to be negative infinity to 1. I'm going to include 1, and I never include infinity. Okay? So we've looked at some examples of cubics and quartics, or fourth degree graphs. Now we're going to keep going. Okay, so now we're asked to guess what a fifth degree function or a sixth degree function would look like. Well, we don't even have to guess, right? Let's take a look at a fifth degree function. A fifth degree function looks a lot like a third degree function, right? Meaning it's got that same, what I call S-curve shape. How about a sixth degree function? What do we think a sixth degree function is going to look like? It's got that same U-curve. So third degree, fifth degree look similar. Second degree, fourth degree, sixth degree look similar. Turns out there's a pattern here, and the pattern is whether or not your power is even or odd. If we have even power, 6, 8, 10, 12, notice we get that same kind of general shape, that same U shape, 112, that's what I put there. Okay? If we have odd powers, 3, 5, 7, 9, oops, that's 8, 9, let's do 111. We see that S-curve shape there. Okay, so odd powers have this S-curve, even powers have that U shape. Okay, if we know that, we can use that information to sketch a graph of anything. Well, any of those types of functions. So what do I mean by that? Well, let's take a look. Okay, over here, we're asked to sketch a graph of negative x minus 3 to the 8th minus 2. So the first thing we're asked is the basic function shape. What is that saying? That's saying, what is the basic untransformed shape? Well, remember, this is even, and even things have basic shape that looks like a U-curve, okay? And then what have we done to this U? That's the question. What have we done to get the transformed graph? Well, we've reflected it across the x-axis, we've moved it to the right 3, and we've moved it down 2. So we're going to sketch that here on our big graph. So we've moved it to the right 3, 1, 2, 3. We've moved it down 2, 1, 2. So here's the new starting point or vertex of our graph. And then I've also reflected this or turned it upside down. So I'm going to draw my U opening downward. Okay. Well, that's not perfect, but that looks pretty decent. And then let's think about our domain and range. Our domain is still going to be negative infinity to infinity. Transformations don't really change our domain when it started at negative infinity to infinity, right? This is going to get wider and wider and wider, eventually covering all x values. Now our range, clearly there's no graph up here, so our range is not going to be everything. Our range is going to be negative infinity down here, all the way into, where does our range stop? Right here at negative 2. I'm going to include that negative 2. All right, now let's look at our next example there. Okay, so 3 times x minus 1 to the 5th plus 6. All right, so what's our basic function shape? Our basic function shape is a 5th degree function. That's odd, so that means our basic shape is going to be that thing that I call the S-curve. Now, what have we done to that basic shape to get our transformed function? It doesn't have a reflection. There's no negative out in front. It's been stretched by a factor of 3, moved to the right by 1, and moved up 6. So let's see if we can sketch that. So I'm going to start at 0, 0. I'm going to move right 1 and up 6. 1, 2, 3, 4, 5, 6. So there's my new kind of starting point for this graph. It hasn't been reflected, so I'm going to go up on the right and down on the left, and it has been stretched. So I'm going to try and draw my curve a little stretchier than it was before. So something like this. Again, not perfect. This is just a sketch, but it is going to help us with the domain and range. Now again, our domain and range are going to be negative infinity to infinity. This curve is eventually going to hit all of the x values and all of the y values. Okay. Oh, my handwriting is so bad. I'm sorry. All right. Okay, so that's actually going to let us fill out the first part of our little chart up here. Okay, so our little chart, the first thing we have is x to the n, where n is odd and where n is even. So where n is even, that's things like x squared, x to the 4th, x to the 6th, etc. Okay? Things like that, their basic shape is that U-curve. Okay? What's the domain? The domain is everything. Eventually that U is going to expand and hit all of the x values, so negative infinity to infinity. And the range, well, our range of our basic shape starts at 0 and goes to infinity. So our range is 0, including 0, to infinity. We never include infinity. Okay? Now when n is odd, let's switch colors just for fun here. When n is odd, that's things like x cubed, x to the 5th, x to the 7th, etc. When n is odd, we saw that that is the basic shape, what I call an S-curve. Okay? What's the domain and range of this S-curve? Well, the domain is everything, negative infinity to infinity. Eventually, this is going to expand and cover all the x values. And our range is also everything. Up and cover all positive y's, and down and cover all negative y's. Okay? All right, so we're a fourth of the way through our little chart here. Now we want to look at root functions. So let's look at root functions next. All right, so here are our root functions. Okay, so root functions are things like the square root function. Now we looked at the square root function when we started graphing, and we saw that it's this kind of little, I call it a little ski slope looking curve. Starts out slow and grows slowly. Okay, we didn't really talk too much about the domain and range of this, but what would the domain of this be? Well, it's going to start at 0 and go to infinity. So our domain is 0 to infinity. Our range is also going to start at 0 and go to infinity. So our domain and range for this guy are the same. Okay. All right, now that's the square root function. So what about the cube root function? Okay, well, the cube root function, let's think about what that will look like. Now, some interesting things about the square root function. Remember that the square root function could only take on positive numbers. Because, for example, if I plug in -4, the square root of -4 is an imaginary number, and we're not going to graph imaginary numbers. Now, that's not necessarily true for our cube root function. So, for example, if I want to do the cube root of something, if I want to do the cube root of, say, -1, well, the cube root of -1 is -1. Why? Because cube root means the thing that when I multiply it times itself 3 times, so -1 times -1 times -1, I get back whatever was under the root. So with cube roots, we can take on negative values because a negative times a negative times a negative is a negative. So for example, what would the cube root of -8 be? Well, the cube root of -8 would be the thing that I multiply times itself 3 times to get -8. And that would be -2, because -2 times -2 times -2 is -8. So our cube root function, unlike our square root function, can take on negative numbers. So let's look at what the graph of this would be. The graph of the cube root of x. Notice it sort of looks like a horizontal or sideways S-curve. So if I go to sketch this, when we go to sketch this, it's like a slowly growing S-curve. Oh, that's a little bit too crazy. Got that drawn a little bit too big. I'm sorry. Let me try again. There we go. Okay, so it's kind of this slow growing S-curve, curving up this way and curving down this way. Now, if we think about the domain and range of this, domain is going to be everything. We can take on all numbers into our cube root function. Turns out our range is also going to be everything, even though it's kind of hard to see, right? If we zoom out, this graph is continuing to get taller and taller and taller. It's doing so very, very slowly, okay? But it is continuing to grow and grow and grow. So eventually, this is going to hit all of our y values. So -infinity, oh my gosh, to infinity. Okay, okay, so that's our square root graph and our cube root graph. Now, let's see if we can't kind of expand on this and think about what our fourth root function would look like and our fifth root function, okay? So we don't have to guess. We can actually just plug this into Desmos. So let's look at our fourth root function. It looks pretty similar to our square root function, right? In terms of it only takes on positive values, it's kind of a slower growing curve. So our fourth root function looks very looks very similar to our cube root function. No, it doesn't. Our fourth root function looks very similar to our square root function in that it's, oh my goodness. Draw a little set of axes here. In that it only has kind of half of a curve and it's slowly growing. In fact, I probably even should have drawn it slower growing than that. Any guesses about our fifth root? Do you think it's going to look more like a square root or a cube root? Well, let's go ahead and see what it's going to look like. So if we change this to a fifth root, we again get that kind of elongated or sideways S-curve. So our fifth root function can take on negative values, and it looks a lot more like our cube root function. So kind of this slow growing elongated S-curve there, okay? So it turns out, again, this is something that we can generalize. Anytime our root is even, square root, fourth root, a sixth root, an eighth root, we're going to get this kind of half curve here. Anytime our root is odd, cube root, fifth root, seventh root, etc., we're going to get this sort of elongated S-curve shape. Okay. Now, using that, let's see if we can't sketch a graph of the two functions listed down here. Okay. So first thing we need to think about is, what is the basic shape for this function here? Well, our basic shape comes from the fact that this is a sixth root. So our basic shape, I'm going to sketch it right here. Our basic shape would be kind of the half curve here. Why? Because that's an even root, so it's only going to take on these positive values before transformation. Now let's think about what it will look like transformed. So what have we done to this poor thing? We've reflected it across the x-axis. That's going to flip this guy upside down. We've stretched it vertically by a factor of 2. We've shifted to the right 2, and we've shifted up 5. Okay, let's see if we can sketch that. So we've shifted to the right 2, there's right 2, and up 5, there's up 5. Here's kind of our starting point. And then we've reflected across the x-axis. So that means instead of growing like this, it's going to grow like this. And I've also stretched it, so I'm going to draw it a little stretchier than I did before. So something like that. Now again, is this perfect? No, but it's going to give us enough of an idea to do things like find the domain and range. So let's go ahead and find the domain and range. So our domain is the x values. Well, this starts taking on x values here at 2 and continues to take on x values for forever. So that'll be 2 to infinity. I'm going to include 2 and not include infinity. And how about the range? Well, our range goes from 5 down, or 5 to negative infinity. Now remember, we always kind of flip that order and do the smallest thing first. So that is negative infinity to 5. We don't include infinity, and we do include 5. Now, just for fun on this one, since we've got Desmos pulled up, let's go ahead and see what Desmos does with this graph. So we've got negative 2, sixth root of x minus 2 plus 5. That's pretty good. So we've got that starting point at 2, 5. It opens down like this. And again, we can see that our domain would be 2 to infinity, and our range would be negative infinity to 5. So we did a pretty decent sketch there. All right, let's look at this guy. So first thing we want to do is we want to think about what our basic shape would be. So I'm going to draw a little set of axes so we can think about our basic shape. The basic shape of that is that of a fifth degree. We've got our fifth degree right here. That would be kind of what I call the elongated S-curve, something like that. So there's our basic shape. Now let's see what transformations have been applied. Well, we have again an x-axis reflection. That's what that negative in front tells us. This 1/3 tells me it's got a vertical compression. Plus 6 tells me that I'm going to go left 6. That's our horizontal shift. And plus 2 tells me I'm going to go up 2. That's our vertical shift. Let's try and do all of those things. All right, so we originally started at 0, 0. We went right. Sorry, no, we didn't go right. We went left, huh? We went left 6 and up 2. So there's kind of our little starting spot where our S-curve is going to grow from. We've reflected this. So when we reflect it, sometimes I think it's nice to show the reflection. The reflection will look like that. And we've also compressed this. So this is going to grow even slower than normal. So something like this. Now again, this is just a sketch, but it's going to help us get a picture. Okay. And what is the domain here? Well, our domain is going to be everything. It's going to eventually cover all of our x values. And how about our range? Well, this is still growing, even though it's growing really slowly. It's eventually going to grow to cover all of our y values too. So our range is also everything. Okay. Let's go ahead and take a look at what Desmos does with that. So we're going to do negative 1/3 fifth root of, x plus 6 plus, oh dear, there we go, oh dear, plus 2. Okay, there we go. All right, not bad. So again, we've got our little growing spot right there at negative 6, 2, rising to the left, falling to the right. So not too bad there. All right, so now we're going to add 2 more things to our little list up here. So now looking at our root functions, okay, we know what happens when we have an even root, so something like the square root of x, or the fourth root of x, or the sixth root of x, right? We're only going to have half of a curve. It's going to be that slow growing curve like that. The domain of our untransformed graph is 0 to infinity, and the range is also 0 to infinity. Now, how about if x is odd? If x is odd, we're talking about things like the cube root, the fifth root, etc. Okay, seventh root. And when we have that, we're going to get both sort of halves of this graph. So I say that this is kind of an elongated S-curve. Looks similar to this S-curve here, but it's much more kind of slow growing in both directions. Now in this case, this is eventually going to expand to cover all x values, so our domain is everything. It's also, even though it's growing slowly, going to eventually grow to cover all of our y values, so our range is also everything. All right, we're doing pretty good. We're halfway done. Okay, so we're going to keep going in the next video and look at our last two little guys here, 1 over x to the n and the absolute value of x.